Welcome to section 5. In this section, we are going to be focusing on collaboration with Git. We're going to look at concepts that are very important, especially in the enterprise environment. But before we get started, there are some things, of course, you need to have so that you can be successful in this section. The first thing you need to have is Git bash. The next one is Visual Studio Code. Of course, we did install these tools in section 2, but again, I just want to make sure that you have both of them. To be able to see whether they are already installed in your system, you can come here to the start, and of course, you can check for Git. And of course, when you do so, you can see that we do have the Git bash. You can click open, and of course, it's going to open the Git bash terminal. The next tool you need to have is a Visual Studio Code. See it here. As far as you can see the app, this is a confirmation that you do have the Visual Studio Code. From there, I want you to come to this location. You need to look for what we call the File Explorer. Click on it. And of course, it's going to open this window. I want you to go to your desktop, right click on this. And of course, you need to go to Show More Options. And here you need to look for the feature called New. Click on the folder, and what we are doing here is to create a new folder. The name of this folder can be Git, Git, hyphen, practice. Enter, and of course, this folder is going to be created here for you. There are two ways you can open this folder, but in this video, what I would like you to do is to right click on this, go to More Options, and look for the Git bash here. So we want to open this folder, click on this, and of course, this terminal is going to open. Now we can let this one go. We don't need this File Explorer anymore. Now we already have our Git bash terminal with us. I'm going to increase the font size by doing Control+. And I'm going to run the command ls. Of course, we don't expect to see anything because this is empty. Now, if you remember in section 1 and 2, there is a way you can move from the Git bash to your Visual Studio Code. And you can type the command code space dot and enter. When you do that, you are going to see that a new window is going to open in Visual Studio Code. Before, of course, we come to Visual Studio Code, let's go back to the Git bash. Since we are done with the Git bash terminal, exit it. Now we are here at the Visual Studio Code. All you need to do is cancel welcome. Again, you can click here, and of course, this folder is going to move up. After this, you need to look for the feature called terminal. In my case, because of the font size, it is actually hidden among the 3 dots. I click on it, and of course, you can see the terminal here. I go straight to new terminal, and when I do so, terminals are going to open. Of course, there are many options of different kind of terminals you can use. As you can see here, we are getting the default terminal, which is a PowerShell. However, if you click on this arrow, you can see that there are other terminals that are available for you to use. I want you to click on the Git bash because we are going to use that one. And now we are exactly in this terminal that will allow us, of course, to run a few bash commands. I can do ls, again, it should be empty. You can run this command pwd, which is going to tell us exactly the printing working directory that we are in. And of course, we can see that this folder that we created specifically in the desktop is actually here. go ahead and clear this. In section 2, we went through the features and of course the life cycle of Git. And also, of course, we looked at the GitHub. When we were looking at the life cycle of Git, we saw that the first thing you need to have is a working directory. The working directory is very important. This is because this is where we are going to put the files that are pertaining to the project. In this case, we don't have any. Let's go back to the notes. Now we can focus on the notes and the concept, of course, we need to know. The first concept is git pull. The question is, what does this command do? And the answer is very simple. The git pull is a command that is going to combine two actions. The first action is fetching the changes from the remote repository. And of course, it's going to merge those changes to the branch that we are currently in. It's important to remember that this is just a shorthand for running git fetch, and then, of course, you follow by git merge. To be able to demonstrate this command, there is something I want us to do. We are going to go to our GitHub where we have a remote repository. If you remember, or if you have gone through section 1, 2, 3, 4, you're going to see that this is a repository we created in one of those series of videos. If you don't have this repository with you, I'm going to add a link in the description section of this video, and of course, you can have access to it. Make sure you do have the GitHub account. To open a GitHub account is very simple. You can go online on any browser, you type GitHub, and you can see the process that you need to go through, of course, to sign up for an account. When you are done creating an account, you can, of course, click the link that is going to be in the description section. And then when you do so, it's going to open like this. That repository will still be mine. You need to fork it. Forking means you're getting a copy of this repository. And of course, you are going to be taken through a series of steps. And when you are done with those steps, you should have a copy of this repository in your own GitHub account. When you get to that point, the next thing to do is to bring this remote repository in your local working environment. To do that, we're going to come to this green button here, and what we need is to click on it. When you click on this, you're able to see a HTTPS link that is given to you. This is a link that goes straight to this Git repository. You're going to copy this link, and then, of course, you are going to come to Visual Studio Code, make sure you have the working directory. The first thing, of course, before we can do anything, is to check whether we have Git in our system. To do that, we have to run this command, git --version. You enter, you are going to see that, yes, we do have the Git version with us. The Git is installed. And of course, we have 2.42.0, and it's for Windows version. Another way you can do this is to type the Git. In this case, Git is just a binary. And if it's installed, it's going to give you some information on how to use it. Let's enter. Yeah, you can see now we do have information on how to use Git. We clear this. Another way, of course, to check whether Git is here, of course, you can do the version, and of course, you can just run the binary, which is Git, and that should give you exactly the version you have, and also should help you to confirm whether Git is part of your system. There are a few things I want you to focus on here. The first thing is the branch that we are seated on. As you can see, at the moment, we are seated on the main branch. Another thing I want us to focus on is this command. This command is going to help us to see exactly the folders that are hidden by the system. If you enter, you're going to see dot folders. Of course, if I just run ls alone, I won't see these folders because by default, they are hidden by the system. Clear this. I just want you to remember Git, if we are having a Git repository, we should be seeing .git folder here, which means we don't have a Git repository here. And then what we need to do to have a Git repository, we can either create a new one or we can work with an existing one. In our case, we are going to be working with an existing Git repository. We clear this. Do that, everything start with a Git command. We're going to do git clone, which means we are cloning repository that is remote, and we are bringing that repository in our working directory. Of course, we copy the link. If you remember, now all we need is to paste. And then, of course, enter. You are going to see that, yes, we have a folder that has been brought in our working directory. Let's clear this. Let's do ls. Yes, we can see a new folder. This folder contains, of course, our Git repository. If we do ls-a, there is still not .git folder here. So what do we need to do? Need to, again, let's clear, let's do ls. We need to change directory and enter into this Git folder. We do that, something has happened. Of course, we were on the main branch, and now we are actually on the master. Something else, if I come and do ls-a, now can be able to see that I do have the .git folder with me, which means now this is a Git repository. Also, you can see, of course, this folder, this file, not a folder. This is nothing but is a bash script file. It's what we saw in the remote repository. We also saw the README file. So if we go back to our remote, you are going to see that we do have these two files here. Now, what has happened is that we have gotten a copy and we have brought that copy to our working directory. Now, this is specifically become a local repository. We can make some changes as we want. And of course, after making changes, we can always commit those changes back to the remote repository. However, we need to remember that what we want to do is to demonstrate how Git pull works. To do that, I want us to go to this remote repository. And I want you to just imagine something. Remember what we said when we were going through the concept of Git. We say that Git is a distributed version control system, which means it allows multiple developers or multiple engineers to work on the same project without any issue. And this is why some people say Git is great for collaboration in projects. As a result, in some cases, you are going to be working on the same repository and you are working in it as a team, which means some people will make changes into this repository and you are not aware of what changes they have made. And remember, at the point of you making a copy, which means cloning this repository, you clone this repository at a given state. So whatever changes that are added after you have been able to clone this repository, they are not directly added to your local repository. Therefore, in most of the cases, when you're working as a team, your local copy of your repository is always going to be behind your remote repository. And this is where the git pull, git fetch, and git merge commands become very important. So we are going to assume that somebody has made some changes to our README file while we were working on the copy that we cloned before the changes were made in our local environment. To do that, we are going to come and edit the README file. We can add any information. For instance, we can say we are going to run this in our Ubuntu server. Now, of course, if you make some changes, you have to commit the changes. Commit the changes, and of course, we are good to go. Then what we need to do is to go back to our Visual Studio Code. Again, we can do ls. Of course, we can see that we do have the patch management script, and also we do have the README. We are going to make a slight change, just one change, and we can make that change in our patch management.sh. And the reason I want to do that is to help you remember the Git commands that we used when we were going through the concept of the Git lifecycle. So this time I'm going to make all the changes in the Visual Studio Code. I can do it using an editor, and in that case, I'm going to actually do both so that you have an idea of how to use both skills, of course, to make changes to the files. I'm going to click on patch management. Of course, when I do so, this script is going to open. Now I can come to line 20 or 21, and I can add another simple command. It is going to help me to check the date. Sudo date. Of course, you can see that you 1 second ago uncommitted changes. Git is very advanced. It notices anything that you are doing to the Git repository. Now, what I need to do is to save this. The question is, how do I save this in the Visual Studio Code? And the answer is very simple. You are going to come to the file, you're going to look for the save, and then you just need to save this. And when you do that, you're done. Clear this. Now, let's remember the command that we used when we were going through the concept of the Git lifecycle. We started by checking the status of our repository, of our Git repository, and of course, we can see that we have made some changes to the patch management.sh. Clear this. The next thing we need to do is to add the changes or stage the changes that we have made in this script. And we can do so by using this git command. We enter. Now again, we can do git status. And of course, we can see that yes, we have been able to stage the changes. Now, what next? We can clear this. And now we need to commit the changes to our working directory or commit them to the master branch that we are on. To do that, we're going to run the command git commit -m, which stands for message. It's nothing but it's just a flag that is going to introduce the message that you want to be associated with your commit. Now, what we need to do here is very simple. We need to say exactly what we did. We can say we added sudo date command in our we can say that we added the sudo date command in our patch management.sh, patch-management.sh. Now, there is something here you need to notice. If you are using a double quotation at the beginning, also make sure you close with a double quotation. Now, after that, you can use single quotation. You can start with a single quotation, and of course, you can close with a single quotation. However, you cannot start with a single quotation and then close with double quotation. It's not going to accept. Enter. Clear this. Now we can do Git status. And you can see now that we have committed the changes to our working tree. Now, as you can see, everything is good to go. We clear this. Now, what we need to check is whether we do have a remote repository here, or we can check whether we do have a connection between the remote and our local repository. We can do that by doing git remote, and of course, we can do origin. As far as you don't get the origin, that's a clear indication that you don't have the remote repository connected to your local repository. So we clear this. Now we come here and push git push origin master. Again, go to use this command to push the changes that we have made in our patch-management script to the remote repository. We enter, and of course, the changes are going to be rejected. Let us see the reason for these changes being rejected. Of course, we can see the message saying updates were rejected because the tip of your current branch is behind. Its remote counterpart, if you want to integrate the remote changes, we need to use the git pull command. Now, this is the time to know exactly how to use the git pull command. Before, of course, going and making sure that, of course, you have to make sure all the changes have been added, committed. But before you go to push, let me recall this command. Before you run the git push origin master command, it's very vital you run this command. And the reason you want to do so is what we said. Of course, you don't know who has made some changes ahead of you. By the time you got a copy of this remote repository, there were people who happened, of course, to add some changes after that. This is because you're working on the same project with other people. And since you don't know, of course, the changes they made, Git is always going to be very helpful by helping you to integrate the changes that were made, of course, after you got a copy of this Git repository before pushing the new changes that you yourself has made to this repository, to the remote repository. So we're going to enter. Of course, you can see that something has happened. Let's go to our README and let's make sure that the changes that we added on the remote repository have actually been added here. And as you can see, the changes we added on line 17, which says we are going to run this in our Ubuntu server, they have been brought to our working directory. Now, there is something you need to notice here. The git pull command did two things. It was able to bring the changes to our local repository, and at the same time, it was able to bring the changes to our working directory. We clear this. Now we can go and push. And as you can see, we have now succeeded. And that is how you use the git pull command. Let's go back to our notes. We are now going to focus on the next command, which is git fetch. Let's hear what git fetch does. The git fetch is a git command that retrieves changes from a remote repository without automatically merging them into the local branch. It updates your local copy of the remote branch, but does not modify your working directory. This is something that you need to really notice. This command is going to fetch the changes from the remote repository, but of course is not going to merge into the current branches or the branch that you have. After fetching, you can inspect the changes and decide whether to merge them using the git merge or git rebase. So you can use git rebase or you can use git merge. We are going to see that. Let's go back to our remote repository. Let's come to our patch management.sh. And I want to make a modification. And to do that, I'm going to go to line 23, and I'm going to add another command. Sudo, I can do something here. I can check for the number of CPU. And of course, I can come and commit the changes. And from there, we are good to go. Now, I want to come back to my local repository. And I want to make another change in the README file so that we can go through the Git lifecycle. Of course, I'm going to go to line 19. I'm going to add another statement. I'm going to say Ubuntu. So I'm going to say Ubuntu is used by 34% of the organization. It's not a must to be 34. This is just a description I want to add. Then I'm going to come here and I'm going to save this. Then we are good to go. Now we start with the command git status. To enter, of course, you are going to see that we have made some changes to the README file. We're going to clear this. And of course, now we need to add these changes, so we need to stage the changes. To do that, as a command, we can check the git status again. And we are going to see that, yes, have been able to stage the changes. We're going to clear this. We need now to commit the changes. We need, of course, to include the flag that is going to help us to pull the message. We can say exactly what we did. We added some So we are going to say we added some description in the README file. Or there is a misspelling mistake here. The README file. When you are done with this, you can enter. Then you can clear and you can do git status. Of course, you can see that, yes, we have been able to commit the changes to our working directory. And from here, what we need to do, you can go and try to push. Of course, it's not going to push, as we saw when we were demonstrating the git pull concept. So of course, you're going to still get the same error. Before, of course, you can go to push, it's very important you do the git fetch. But this time, I want us to pay attention here. Of course, we did edit the script and we added another command. And that command we added is sudo nproc. Now, we want to make sure when we run the git fetch, we want to compare with the git pull to see whether the changes that we made in the remote repository are actually going to be brought in our working directory. So that is the observation we want to make. So I'm going to enter, and nothing, as you can see, nothing has been brought to our working directory. Because remember we said our working directory is where we have the files that pertains to the project. As you can see, nothing. So what do we need to do if we want to bring those changes to our working directory? This is where we call the command git merge. See what will happen, enter. As you can see, the end block now, the changes that we made in the remote repository has been added to our working directory in the local repository. And now that is how the git fetch works. It's a combination of git fetch and git merge if you want to bring everything to your working directory. Let us go back to the notes. Now you might be asking yourself, then which one should I use? Git pull or git fetch? In the enterprise environment, the git fetch is always recommended. It's important for you to keep fetching the changes as you continue to work on your local repository. And then, of course, when you are ready to push, you can first of all do the git merge. And if you don't have any conflict, there is no issues with your changes, you can go ahead and push the changes. Let's actually do that. Git push origin master. And of course, you can see that now we don't have any issue. We are done with that concept. Next, we come to the git merge. We already saw the git merge, but again, in this case, I want to give you some more description of what this concept does. The git merge, of course, is a git command that is going to combine the changes from different branches. It will take the content of the source branch and integrate it with the target branch. As you saw, of course, it was able to take the changes from the remote repository, of course, and then was able to integrate those changes with our local repository. By doing so, it was able to bring those changes to our working directory. But for you to be able to fetch the changes from the remote to the local repository, you still need to run the git fetch command. Then, of course, to combine the changes of two branches, the source and the target, you need to use the git merge. The result of running the git merge command is usually a new commit on the target branch that represents the changes from the both branches. So it's like combining the history or the changes of the branches that you have. So we have the source branch and we have the target branch. When we run the git merge, it's going to combine the changes in both of them. And we are going to have one commit that is a combination of the changes from the two branches. Can't be more than two, but the concept is what I want you to truly understand. Now we have git rebase. Git rebase is another concept that you need to understand. Git rebase and git merge are somehow related, although they don't work the same. The git merge is going to take, of course, the changes from the source and the target and combine them to make one commit. That is a combination of the changes from both branches. So when you run the git merge, we still keep the history the same, except that we combine both history. What about the git rebase? The git rebase is a git command that allows you to modify the commit history by moving, combining, and deleting the commit. I want to say this. If you are not conversant with Git, it's very important you don't really run the git rebase. However, when you understand the difference between the git merge and git rebase, things become very easy. As you are seeing here, what git rebase does is actually going to give you what we call a clean and a linear project history. So instead of taking the changes from the source and the target and combining them into one commit that consists of the changes from both branches, the git rebase is actually going to rewrite, modify, and delete the commit. And by doing so, we're going to have one linear clean history of the project. But that history has been rewritten. Unlike the Git merge, which create a new merge commit, which consists of the history from both branches that were combined, Git rebase is going to integrate changes by moving, deleting, combining, and of course is going to apply commit from one branch onto the other. And the new change that is created by the Git rebase might not be similar to the commit history from the two branches that you combined. It's always going to create a whole new history. And that history is going to be linear. That is one advantage of using Git rebase over Git merge. Git merge is going to smash all the changes into one commit. But we are not going to lose anything. The changes will still be there as they were before. But the Git rebase is going to rewrite the changes. And we are going to have one linear, nice history. So you can see an example here I'm given exactly on how to use Git rebase. This command rebase the current branch onto the main branch. The current branch is the one that you are in. Let's come to Visual Studio Code. I'm going to run a command to check the branches here. We have only master. Let's create another branch. I'm going to say git branch, say main. Of course, we can do that. Let's create another one, git branch, let's say shopping cart, hyphen. Now let's do git branch. Of course, now we have 3 branches, but you can see the green branch is the one that we are on. It's a current branch, as you can see. Now let's switch to the main. You can do that by saying git checkout main. Of course, when you do so, you are now in the main branch. Let's clear this. Let's do git branch. You can see now the green one, this is the current branch. Let's go back to this, and we can say that if we run the command git rebase main, this command will rebase the current branch into the main branch. So if we come here and say git rebase master, it's going to rebase any changes that we have made in the main branch and will rebase them onto the master. Press enter. Current branch main is up to date. Of course, we don't have any changes. Something else, you can also interact with the rebase, allowing you to squash, edit, reorder, or delete commits. You can use a git rebase, which is this command, and this command will open an interactive rebase dialog for the last 3 commits. Let's see how it works. This, come back here, going to clear the terminal, then we enter and we see. This is the, as you can see, this is a new terminal that has just opened. We did update the README, if you remember. We added some description in the README file. That is a message, of course. We also updated the patch management.sh. That's all we did. And you can see the linear history. We can pick one or decide not to, but this is the interactive terminal, or we can call the interactive environment for the Git rebase. Now, how do we come out of this? We can go on our keyboard and we can click I, which allow us, of course, to edit this, any information that is inside of this editor. If we want to come out of the insert, we can press escape. If we have done anything like, so we have written information, we have squashed, maybe you have edited, we need to save information, we need to do shift colon. As of course, you can see something appearing here at the bottom. You can do X, an exclamation mark, and you can come out. Successfully rebased and updated, as you can see. So that's something that is very nice. So clear this. Now we can switch back to the master, git checkout master. Of course, we clear this and we come back to our notes. We are done with the rebase. Now we come to another concept called Git strategies. I want to say this. There are many different Git strategies. But the one that we are going to be looking into is what we call the feature branch workflow. Sometimes it's also called the feature branching strategy. The feature branching strategy. Or we can call it the feature branch workflow. It's very important, especially because it helps us to create a new branch for each new feature or bug fix. When we talk about the features, I know you might be confused, but I want you to look at the software. The software can be anything. You can relate to your e-commerce. All those functionalities you see, they are actually features. For instance, one thing that is very common and is very famous is the shopping cart. If a shopping cart has an issue, we can create a feature branch that is related to the shopping cart, and we can be able to fix the issue related to that. We can be able to develop and test the feature in isolation on the branch. Once the feature is ready, we can merge the branch back into the master or main. And main is where we have the quality code base. Let's demonstrate this. We are now going to demonstration. We are back here. To demonstrate this, we are going to first of all see exactly how this works in the enterprise environment. To start, you have to know that most of the issues at the workplace are created in the form of tickets. Therefore, if you are going to create a feature branch, it has to have some naming convention. The most naming convention that I have seen usually going to start with a ticket ID slash the name of the feature. We will start with the ticket ID, the name of the feature, and so it's going to look like this. This is just one naming convention. There can be others. So now I'm going to enter. Doesn't mean anything. It's just going to throw an error. But I want us to use this as a reference. To create a new branch, of course, we know what to do. But this time I'm going to use another command, which is git checkout -b, which means my aim is to create a branch and check and switch to that branch. And to do that, you can use the command git checkout -b. Let's assume the ID that is related, or the ticket ID that is related to this issue is 1, 2, 3, 4, 5, 6. This is just an imaginary number. Slash, of course, it's a shopping cart that has an issue. Slash, the name of the developer. Maybe we can even put the date, but this is the most common naming convention. You enter, and of course, now we are going to be on this branch. We can make any changes as we want, and then when we are ready to merge, we can merge the changes after testing and verifying that the changes are working.
we can then merge into the main code base, either on the main or the master branch. And that's exactly how it works. So this is a concept you need to master. It's what we call the Git strategies. The feature branch workflow, or what we call the feature branching strategy, is very famous. We continue with the Git strategies. In this case, I want us to look at the Git log. When you come and run the Git log, what happens? So I'm going to come here and say Git branch. And of course, I want to switch back the master. Git checkout, master, enter, clear this. Now what we need to do is to come and see exactly what this is. The Git log, of course, will tell us information. We're going to see here is going to give us information about the commit that we have. This is why Git is so important, because it keeps track of the changes that we are making to a specific repository. Let's come here to the notes. As you can see, we have this number. This is a 40-character string. A string is nothing but is just a combination of numbers and letters. And as you can see, there are 40 of them. This is what we call the unique identifier, or what we call the hash. And this is what is going to make each commit unique. It's used to identify each commit because it's going to be unique and different from the others. The next thing you need to pay attention is the head. As you can see, the head here is shopping-feature. This was another branch that I made. And then, of course, we have the master. This indicates the current branch and its position. Let's go back to the Visual Studio Code. We can see that now the current branch is actually the master. Can we verify that? Yes, it's actually the master. We go back here to the notes. And that branch is also merged into the master branch. The head is a reference to the latest commit in the current branch. That's what it is. We continue. We can see who authored the change or the commit. And this is going to show the order of the commit along with their email. So you can see who did it, and the email is also available here. In this case, this is the person that authored the commit, and this is their email. That's not all. We are also going to see the date. This indicates when the commit was made, and as you can see here, the commit was made on Wednesday, January 3, 13, 10, 37, 2024. And this is the time. Don't know what this is, but yeah. So it was made exactly what you can see here. Let's go back to the Visual Studio Code. As you can see, we have, of course, the identifier, the hash. We have the head, which is indicating the current branch that we are in. It's actually the master. We can see the merge, we can see the order, we can see the order email. We can be able to see exactly when the commit was done. And of course, this is the year. I'm not familiar with what this is it. But again, this is the history itself. Now, if you are done with this, you have these you have this section. What you have here is a column. So all you need to do is to type Q. You are going to quit and return back to the terminal. Clear this. Let's go back to the notes. We are done with that. Then we come to something that is very important, the Git conflict. How do you handle Git conflicts? In Git, a conflict is going to occur when a version control system is unable to automatically merge changes from different branches due to the conflicting modification in the same region of a file. This conflict arises when two or more branches have made changes to the same part of the file, and Git cannot determine which changes to incorporate. In simple terms, I'm going to demonstrate how Git conflict occurs, and we are going to see exactly how we solve it. And by the end of this, you should be very familiar with how the Git conflict works, specifically in the enterprise environment. So we're going to go back to the Git remote. In the Git remote, I want us to make a specific change. And I want us to be very specific here because I want us to cause a conflict. So we are going to go to line 24. Note this, line 24. Actually, let's do line 25. Line 25, I'm going to edit. I'm editing on the patch-management.sh, specifically on line 25. I'm going to put just a simple Linux command. And this command is lsblk. Now, what I'm going to do is to commit the change. Of course, I'm going to do that. And after doing that, I want us to go back to our local repository. This is our local repository. Let's go back to the notes. Remember, for a conflict to happen, the conflict is only going to happen when two or more branches have made changes to the same part of the file. So let's return here. We have this patch management.sh. And of course, we went on the remote, and on the remote repository, we made a change on patch-management.sh on a very specific portion. Of course, we made the change on line 25. Now we are going to come to local repository, and we are going to go straight and make change on line 25 because we want to cause a conflict. And we are going to have to put some information. We can say, can actually just put in a command, even put pwd. Now we have written on the same file, on the same place, we have made some changes. And remember, in the remote repository, we have made some changes specifically on the same file, but on the same line. And we are doing the same on the local repository. Let's make sure we save the changes. We are good to go. Now, after this, we're going to go through the normal Git lifecycle. We start by saying Git status, pause. We add the changes. We clear this. Say Git status. Come and say Git commit. Can say modified. We can put this message, modify the patch-management.sh. Enter. Clear this. And now, before, of course, we can push, because if we try to push, of course, there is an error we are going to get as we saw earlier. So what we need to do, we can either do git fetch or we can do git merge. We can do git fetch and then git merge, or we can do git pull. I'm sorry for that. Let me repeat that. To be able to fetch the changes from the remote repository, we can either do a one-time command, git pull, or we can do the most recommended one, which is a git fetch. And then, of course, to bring that changes to the working directory, we can do the git merge. For that case, I'm going to do git fetch and git merge. Now, to do that, we're going to say git fetch. Of course, we don't expect anything. Line 25, nothing is happening. Let's now go ahead and do git merge. I'm going to clear this. Come here, pull this one down, and then I'll say git merge. Enter. And of course, we did expect this is going to happen. This is what we call the Git conflict. Now we have a conflict here. The next question is, how do you solve a conflict? Let's first of all see what this conflict pertains. As you can see, we do have a conflict here. We are seeing here, we have either, there are three ways you can solve this. When a conflict occurs, Git also gives you a way to solve the conflict. This is why Git is very, very helpful. We can either accept the current changes, which means we have sudo nproc and we have pwd like this. Or we can accept the incoming changes, which means we're going to have sudo nproc on line 28, and on line 30, we are going to have sudo lsblock. Or we can accept both changes. You can also compare the changes. So the first thing is to compare the changes. As you can see, when you compare the changes, you can see what will happen. That will exactly what will happen to the changes if you compare the changes. So you can even change the lines that you want. So these are all next conflict. You can see what was happening. Now merge. Let's return back to where the conflict is. So you can either compare the changes. Of course, you can see how the changes is. Click this back. Of course, you can accept both changes or you can accept the incoming changes. It's up to you how you want to solve the Git conflict. Let's accept both changes. If you are going to accept both changes, this is how it's going to look like. The Git automatically is going to solve the changes. And of course, it's going to accept and include both changes. Let's go back to the remote repository. We can see that in the remote, we have sudo nproc, we have sudo lsblock. Now, when we come back to accepting both changes, we see that is leaving pwd where we had it before, but is moving lsblock that was also on line 25 to line 28. And that is how Git is going to remove the conflict. Let's resolve in the merge editor. So in the merge editor, we are going to see this in a better way. As you can see, we have sudo nproc, we have sudo nproc here. We're going to look at it in details. You can see that this is what is causing the conflict. On line 25, we have sudo lsblock. This is the incoming. It is coming from the remote. In the current branch, which is what we have here, which is a local repository, we have the pwd on the same line. So the conflict is happening because we have the same information on the same line, on the same file. However, we are being given a solution that is going to solve the conflict we have. And of course, we selected to accept both changes. Now, we're going to accept both changes. We do have pwd still staying on line 25, but sudo lsblock that is coming from the remote repository is being moved to line 28. All we need to do is complete the merge. And when we do that, this section is going to appear. All we need to do is to click commit. And when we do that, it's going to bring this feature that is going to help us to synchronize the changes between the two branches. We click on it, and of course, it's going to bring this window. This action will pull and push commit from and to original master. We say OK, and now you can see that the changes is being synchronized. We have Git cannot open Git fetch, permission denied. Let's see, open the Git log, show command output. Let's see. Can see what is happening here. Let's go back here. Modified or changes. Can see that. Can see what happened. Again, we can see this one. And then when we try to do this, of course, now you can see what is happening. And of course, the commit has been successful. You can also be able to see the logs of how the Git conflict is solving the conflict, and of course, how the commit is going to happen. Let's close this one. We don't need the output. And now, if you come here and enter, this margin should disappear if everything went as it was supposed to go. So now here, if I do control minus, because I want you to see exactly what we have master, and then of course, we have the margin. They are both separated by this line. If everything was done correctly, there are a few things that should happen. If we enter, this margin is going to disappear. See? So everything is good. So if we go on the remote repository and we come here, the Git practice project, we come to the patch management.sh, we come all the way to the bottom, we can see the changes that was made when the Git was resolving our conflict. That is exactly how you resolve a Git conflict. Let's go back to the notes. That's exactly how you do it. And I believe this is going to bring us to the end of section 5. That was a very, very important section. We have seen many concepts that are very important, not just to you understanding Git, but also these are some of the questions that you are going to face when you are going for interview, and they are specifically focusing on your knowledge, especially on how you can use the Git, the GitHub, how you solve conflict and all that. Thank you so much. I'll see you in section 6.